We're going to jump back now to equations that have two variables. And we're going to talk through how we take those equations and we put them on a graph. We did a little bit of this before, but we need to do a little bit more now and get back to this idea of lines. Please make sure that you have this worksheet in front of you and that you're ready to follow along. The first thing we'll do is fill out the plain area in the upper right-hand corner with some reminder information because we haven't done this in a long time. First of all, we want to remind ourselves of our most famous equation, which is your blue y equals yellow m times your pink x plus your green b. Okay? Those are the four elements in most important equations. You have to have an x and a y, your pink and your blue. You have a slope, and then this b was your y-intercept. That was the point. And I think I'm going to write this in green since that matches b. Your b is your y-intercept. And intercept sounds enough like, I'm going to write a little neater here. Intercept sounds enough like the word intersection. That should help you remember that it is the point where your line intersects the y-axis. So y equals mx plus b is the format that some of our equations are given to us in. The other format that is given to us is called standard form. And standard form was the one that had really no good information. It had some number times x plus some other number times y, which was equal to another number. And those capital letters, if you remember talking about this before your MCA test, mean that there's no connection to any of these lowercase letters. The only thing we know for sure is that it's a line because it's got an x and a y. It's a function, it's a line on a graph. When we had these types and we were practicing for a test, we used the strategy of making a table, right? And finding the point, making an XY table, I should say, an input-output table, and finding out what happened in that table when x was 0, what did that make y? And then we tried when y was 0, what did that make x? And we use those to graph. So that's going to be your strategy on here for the equations that appear in standard form. I'm going to do one example of each, and I think I'll do number 2. So number 2 is in slope-intercept form, and I know that because when I look at the format, I see I've got y equals mx, and it's plus b, but because this happens to be a negative number, it's really minus b, same thing. So the way that we take this equation and put it on a graph to see what it looks like is we begin with our y-intercept. We know that this line crosses the y-axis, the up and down axis, at -4. So I'm going to start by making a point, and I'm going to leave it green to make the connection to that y-intercept. I'm going to go on the y-axis, which is your up and down axis, and count down -1, -2, -3, -4. So I've already graphed one point. Then I'm going to take a look at my slope, and my slope is 3. I know that in order to do a slope, I really need a change in x over a change in y. I need two numbers. So what I'm going to do with 3 is put it in the format we use when we need to make whole numbers into fractions. We've got 3 over 1. 3 over 1 is the trick you learned in 4th or 5th or 6th grade, that when you're trying to get a whole number to look like a fraction, you put it over 1. So what that tells me is that my change in y, or my numerator, is 3, and my change in x, or my denominator, is 1. What that means on the graph is I'm going to start building my graph from my y-intercept. I'm going to build 3 up, one, two, 3, and I'm going to go over 1, and then I'm going to make another point. Remember that this number represents how far away going up and down the 2 points on the line are. And this represents how far left or right the 2 points are. So when I have my slope, I can make one more point on the line. And actually, if I wanted to, I could keep going. If I wanted a really accurate line, I would then start from this point and say, I wonder where the next point on the line would be. Well, I know that the change in y from this point to the next has to be 3. So I need to travel up 1, 2, 3. That's my change in y. And I know that my change in x is 1, which means I need to go right or left 1. I can make another dot at that intersection, and now I've got the beginnings of a pretty decent looking line. I can connect the dots, put my arrows on both sides, and I've got it. Maybe we should try one more like that. Let's try this one. All right, once again, I know that this is in slope-intercept format. I've got my y, my slope of 2/5, my pink x, and my green y-intercept. So let's go ahead and start graphing the y-intercept. We know that our line crosses the y-axis at +2. So go to your origin and go up 2. There's my y-intercept dot. Now I need at least one more dot to make my graph. So I'm going to use my slope. My slope was provided to me with a change in y of 2 and a change in x of 5. Remember, your slope has your change in y on the top, and it has your change in x in the numerator. So what that means is, moving from one point to the next on this particular line, I would have to travel 2 up and down and 5 left to right. I also know with a positive slope that by the time I'm done with this, I want my line to be going up from left to right. So I have to pay attention to that as well. I am going to take my y, change in y of 2. I'm going to start at my dot, and I know that my next dot has to be up 2 and then over 5 away from the other dot. So if your slope is a change in y of 2 and a change in x of 5, that works. And then I need to connect my dots and make some arrows. Now, the next scenario, you've got a couple more of those. Your next scenario is that you have an equation in standard form. And when we had equations in standard form, we were graphing them using this strategy. We were making a table. We were actually looking to find the slope and make it into slope-intercept form. But this also works for graphing. We're looking for our x and y values. We need at least 2 points to make a line. So if we can find 2 points from the equation here, we can make it work. So what we did when we were looking for the slope and trying to graph this is we were looking for what happens in our equation if we take our x, which is right here. If we take our x out of the equation and replace it with a 0, what does that do for the solution of y? So the way we did that before your test is we would replace our x value with a 0, keep everything else as is, and as a matter of fact, we kind of used to cover this up with our hand and say, okay, if our x is 0, that makes our y 2, because 2 times 2 is 4. So if your x is 0, your y is 2. So I'm going to put a 2 here. Now, if you don't understand where I got that, I covered up this 0 because zeros don't matter, and I decided I needed to find out 2 times something equals 4 to find my y. So I knew that 2 times 2 equals 4, which meant my y was 2. Now what we did is to find another point and find it easily, so we decided to say what would happen if our y were 0. So what would happen if I took out this y and replaced it with a 0? So what that looks like is x plus 2 times 0 equals 4. We know that 2 times 0 just equals 0, so that takes that out of the equation. And what I'm left with is if y is 0, x is equal to 4. I didn't even have to do any math there. So now, because you've got 2 points to work with, you can make the graph version of this line. You can take the point over 0 and up 2, start at your origin, and go over 0, up 2, make a dot. And then you can go back to your origin and go over 4 and up 0. And there you go. You've got your line.